Good day, everyone. I am Eunice San one of the reporters for today's discussion. As you can see on the screen, our topic is about the solubility of drugs. But first, what is solubility? Solubility is the relative ability of a solute to dissolve in a solvent. It is measured in terms of the maximum amount of solute dissolved in a solvent at equilibrium. The resulting solution is called a saturated solution. Certain substances are soluble in all proportions with a given solvent, such as ethanol in water. This property is known as miscibility. Thus, solubility of one fluid in another may be complete or partial. In general, like dissolves like. For example, aromatic hydrocarbon dissolve in each other but not in water. Under various conditions, the equilibrium solubility can be exceeded to give a so-called supersaturated solution. The solvent is often a liquid, which can be a pure substance or a mixture. On the other hand, the solute can be a gas, another liquid, or a solid. Solubilities range widely from infinitely soluble, such as ethanol in water, and poorly soluble, such as silver chloride in water. The term insoluble is often applied to poorly soluble compounds, though, strictly speaking, there are very few cases where there is absolutely no material dissolved. The process of dissolving is called dissolution, a relative straightforward for covalent substances such as ethanol. When ethanol dissolves in water, the molecules of ethanol remain intact but form a new hydrogen bonds with the molecules of water.
For the effect of pressure on solubility, the second factor, pressure, affects the solubility of gas in a liquid, but never of a solid dissolving in a liquid. When pressure is applied to a gas that is above the surface of a solvent, the gas will move into the solvent and occupy some of the spaces between the particles of the solvent. This gas pressure factor is expressed in Henry's law. Henry's law states that at a given temperature, the solubility of a gas in a liquid is proportional to the partial pressure of the gas above the liquid.
Effect of temperature on solubility. For the majority of ionic solids, temperature is in direct relation to the solubility, while the gases have inverse relation. For solids, the solubility increases when temperature rises, since all particles of the solution gain kinetic energy, which causes them to move faster. For solvents, it can cause more collisions to the solute particles. For solutes, it can break bonds easier. Adding them will cause the solubility to rise significantly. Gases have inverse relation since gas molecules can actually escape the liquid with more kinetic energy, thus decreasing solubility. Effect of surface area to dissolving rate. Surface area can cause an increase of rate of dissolving of a solute. An example would be dissolving a block of sugar versus sugar cube versus dissolving the same amount of sugar but in small crystals. There are more contact surfaces in sugar crystals than in a sugar cube. Because of this, more solvent molecules can touch the molecules of sugar crystals, dissolving them quicker than a block of sugar.